Okay.
Okay.
So how's this with you?
It's okay. I've done a lot of math. I didn't do very well by myself on chapter 5.
Oh
Unless
yeah.
yeah, on that test, I didn't do well at all. So I just, I'm going to be studying that this week and then this.
Uh-huh.
Yeah. How are you doing?
Okay, I think. I don't
Good.
know.
Good.
I need to coming up and I need to work on remembering from previous week.
Yes.
I'll need to go through and go through notes.
Yep. With for the exam, is that what you're saying?
Yeah.
Yeah, yeah.
I think our exam is this week.
I think next week.
Yeah.
Yeah. There's
You're right.
Britain. Oh, Britain dressed up for the occasion.
No.
You look nice.
Oh, thanks. Yeah.
Yep. Yep, you're out dressing us today.
No, I just figured I'd run up to the devotional in a little bit, so.
Oh, yeah. What a
Good.
great opportunity.
Yeah. Should be good.
We will. What time does that start there?
I think it starts at 2.
Okay.
Yeah.
That's great.
Awesome.
It is awesome. Hopefully we can see it via internet if that works.
Yeah, where are you guys located?
Arizona.
Are you in Arizona?
Yeah.
What? Why did I
I'm in.
I just forgot.
Yeah, I'm in Peoria. Just like 5 minutes from the new Phoenix Temple.
Oh,
Oh, nice.
Yeah. Wait, I can't hear you. What?
I'm like 5 minutes from the Temple.
Okay, it's not. I can't hear you. Darn.
Yeah, I can't either.
Oh.
Okay. Okay, now I can hear you.
Okay.
Yeah. Okay, what did you say? Where are you?
I'm at 5 minutes from the Mesa Temple.
Oh, I didn't know you were in Arizona.
Yeah.
That is so fun.
Funny. Okay, so I mean, it's probably a long but my sister live close to the temple too.
Okay.
These are Christy and Sawtell.
Okay. Like you keep cutting out. I wonder why. Is your mic far away? Let's see. Christy. You said Christy?
She'll grab a microphone.
Okay.
Yeah, it's like echoing.
Yeah. I think she said she knew someone that worked at the Mesa or at the temple, something like that.
Yeah. Something like that. Who knows? Okay.
And Britton, you're in the dorms. Which ones are you in again?
It's called the Towers.
Oh, that's right, the towers. Yeah. My son's in Nauvoo.
Oh, okay. Yeah, that's just right up the street.
Yep.
Okay, can you hear me now?
Yes. Okay.
Yeah.
Something about Christy works at the temple.
So they're right by the temple, and I'm not sure if it's in your state or not, but it's Christy and Kemp Sawtell.
Sawtell? How do you spell that?
SAWTELLE.
Okay. It doesn't sound familiar, but
Okay. I just curious. It's my mom's birthday and sister's mother-in-law.
oh, okay.
So
Sawtell, maybe a different because it's we're in the stake district, but not we're far enough to be in another stake, not by the temple.
okay.
Yeah. So,
Awesome.
I know we're only an hour away. Great. And Natalie's from Idaho, right? Or where is she?
I want to say she's in
Maybe
I
Yeah, I don't know. Has anyone talked to her?
No.
I haven't.
Should we email her?
I haven't gotten anything from email.
Did you guys do the little game that we have to play?
Oh, the random
Yeah.
thing or whatever.
Yeah. Instead of cutting them out and whatever, I'm laminating them. No, just kidding. But random.org. Last time we did random. It's random.org, and it's like a number generator. So and then you just put in minimum 1 to 30 because there's 30 of those things, and then it just picks a number for you.
I used that for it.
Yeah,
Oh, you did?
After I figured it out, then I saw that it was like either you didn't do both. Anyway.
Extra credit.
Luckily, I hadn't spent the time to let them out yet.
Extra credit right there.
I'm trying to get her some pacifier. So she can go to sleep better. But she just chews on it.
She's like, I know what you're up to.
I didn't want to start it too early, but I'm feeling like I'm going to start it too late.
Keep trying. Britton, where's your family from?
We're Pocatello.
Okay.
It's like an hour from Rexburg.
Yeah. Are you adjusting back from your mission okay?
Yeah, it's been pretty good.
Good.
Yep. Took a while, but...
Sure, yeah, my son as well. Hi, Natalie.
There's like a...
Oh, your mic is off.
Can you hear me?
Yeah.
How are you guys?
Good.
Good.
You?
Britton dressed up for us today. No, he's going to that devotional, isn't he lucky?
I'm so.
What?
It delayed. What?
I said awesome to get to.
Your mic is cutting out.
I'm hearing like echoes.
Yeah, me too.
Of myself and everyone else.
Maybe I'll put in earphones too. I have BYU earphones. You see these?
Oh, fancy.
I know. They're. I thought it'd be appropriate.
I don't hear the Jenny. I hear Tori, Britton, and Sweet.
Say that again?
One second. Sorry.
Uh-oh. Oh.
Can you hear me?
Yes.
Yeah.
Okay, sorry. I hope I didn't cough in your ear.
Okay, is the echo still happening? I'm still hearing it.
Yeah, me too.
Oh, shoot.
Is it? Jenny, are you hearing an echo? Because it might be coming from you, but I'm not sure how.
Okay, well, I'm on my cell phone. I'm not hearing an echo.
I definitely hear the echo when Tori and Britton speak, but I don't hear it right now when I'm speaking.
Yeah, I'm not hearing it when you speak either.
Oh, but I don't hear you anymore echoing. You're done.
Do I echo now?
No.
Okay, it's over.
Let's start while we're ahead.
Yeah. Okay, so let's just jump right into it.
Okay.
So did anyone, I worked on both the homework and the preparation assignment. Obviously the prep assignment is the main one that we need to make sure everyone gets, but does anyone have any questions at all? I guess we're supposed to talk about the part 2, like what we all got.
Yeah.
Let me find that. Does everyone have that pulled up?
Yeah.
Yeah.
Okay. So what did everyone get for the mean of their sample? Mine was 49,840.
Mine was 47,120.
Mine was 41,800, and so I think I'm going to try mine again because it seemed really off.
Well, okay, let me make sure I did it right. I know this is like back to junior high or whatever, but for me, you just add them all up and then divide by however many there are, right?
That's what I did.
Okay, that's what I did too.
Yeah, there will be some variation.
Yeah, so is it, if it like falls in that, hey, calm down, baby. If it like falls into that graph, what does that graph have to do with anything?
Well, that's what I was going to ask you. The 41,800, it fell within that colored part of the graph. It's just way on the low end. So does that still mean that it's, the question was, do you think this is unusual? And I don't know if it falls into that, if that means it's usual, or if it's on one side or the other, it means
No, it's normal because it's a normal distribution.
Okay.
And so where it's such a small sample size of 5, it should be pretty normal that it might end up on one of the outliers.
Okay.
That's what I think, at least, just because.
Yeah.
I mean, all of them added together give the sample distribution mean, or whatever it's called.
Mm-hmm.
So I think you're good.
Okay.
Yeah. That's what I was getting to.
I'm on the left outliner or whatever. So I took 5 of those numbers, added them, and then divided it by 5. Is that what you guys did?
Uh-huh.
Yep.
Okay, so I got the 38,160. So I'm like almost off.
Definitely on the lower
Yeah,
end.
on the low end.
Yeah.
Did you guys use that random number thing?
I did.
Yeah, me too.
I did too. Oh.
I didn't. I mean, I did, but not on this one. I played with it a little bit.
Yeah. Okay. So then that was C.
Okay.
We just talked about C on number 7, right?
Yeah. Do you compare your mean from question 7A to the means obtained by at least 3 other individuals? What do you notice? In practice, you only get to see the means from the samples you draw. You do not get to observe any other mean that could have occurred.
So I think that it can just go anywhere between there, right?
Yeah.
Yeah.
What it sounds like.
Yeah.
Yep.
Did anyone have
any questions?
Yeah.
No, that's what they explained in our lesson. I think it was just another example of like reading our lesson number 6. Yeah.
Yeah.
It can be within and not change.
Yeah.
Okay.
Okay.
All right, number 8.
Okay. The graduate admission test is used as an admission criterion in many Masters of Business Administration programs. The scores on the GMAT are normally distributed with a mean of 529 and a standard deviation of 113. Consider a simple random sample, or n equals 10 students taking the GMAT. So what is the shape of the distribution of the sample mean for all such samples?
Normal.
Normally distributed.
Yeah.
Yep.
Normal.
Cool.
And the reason I did that was because it said that the scores on the GMAT are normally distributed. So that would
Yeah.
Yeah.
Right. be okay.
Yep.
Keywords.
Okay.
Um,
How do you know that the distribution of the sample mean has this shape? No, yeah, we answered that already.
Yeah.
Okay. What is the mean of the sampling distributions of sample mean scores for all such samples?
It seems like it's always going to be the same, right?
That's kind of what I understand, yeah.
Like every problem I did, it was always the same as the parent one. Like the sample
yeah.
is always the
Mhm.
same as the parent one. So
Yeah.
Yeah.
I didn't read there was a rule about it, but it just seems like that's just what happened.
Yeah.
Yeah.
I mean, it said somewhere in the reading the mean of the sample means is the population mean.
Yeah, it's equal to that of the parent population. Yeah.
Yeah.
And then what is the standard deviation of the sampling distributions of the sample mean scores for all such samples?
You use that new little equation thing, right? The sigma
Mhm.
divided by.
So it's, yeah, so let me make sure. So it's the population standard deviation divided by the square root of the sample size, right?
Yes.
Is that what that's the sample distribution, that O thing? That's not the sample. Oh yeah, that's the sample size.
That's the,
Right.
yeah,
Yeah.
standard deviation.
So that thing, can you say that word again for some reason? I know I've read it.
Sigma?
Yeah, the sigma.
Sigma.
That's the name of that little sign,
Yeah, sigma.
or Greek.
Okay.
Is it Greek? What are those things?
Yeah, I think they're Greek, but I don't know what the other one is.
And what is that? So the sigma equals the
It's the population standard deviation.
Yeah.
Right.
Is the U-looking thing kappa or something?
Oh, I have no idea.
Okay, I don't know.
Jenny, do you know?
What you think? What?
Like the mean.
Oh,
Mean.
the mean. Oh, I knew this.
That's not important. I was just curious.
It's mu. It's mu. Whatever
Mm.
that is in Greek. It's called. Yeah, the mu. And it looks like a U, but it's really like an M. Mu.
Oh, yeah.
Okay. So did everyone get 35.734?
Yep.
Yes.
Yes.
Sweet.
Hey, I got that lesson.
Good.
Yeah, this
I'm still working on 5, but I got this one.
That's good.
Sorry.
Okay, does anyone have any questions about the homework? If you did it, if not, we don't.
I do.
Yeah,
Sorry.
let me look at it again.
Real quick, it's the X bar, that's just the whole graph, right? It's when it says when is X on number 6 for the part 1, it says when is X bar normally distributed.
Oh, on the prep? Wait.
Yeah. And it says if the data comes from a normal population or if the sample size is big enough. But the X bar, that's just the graph that we've been doing. Like, that's what an X bar is. Is that right?
Yeah. Like that whole thing, right?
Yeah, like the picture on the next, on the part 2.
Yeah, like the little X with the line over it.
No,
Yeah, that's what I was thinking.
that's what the X bar is the X with the line over it?
I think
Yeah,
so.
I have no idea.
I can't remember exactly what it means. I'd have to look at it again, but
No, I wrote
Okay.
all.
isn't it the
It says select 5 to compute the sample mean.
Yeah,
What is the sample mean?
yes.
okay, so the X with the line over it
I just Googled it.
signifies the sample mean?
It's called X bar, and it's a sample mean.
Okay.
Yeah. I'm
Okay.
looking at this thingy. Can you read that?
Yeah.
Yeah, and it tells it also.
Okay.
X.
Wait, hold it up one more time. I didn't see it.
It was on a PowerPoint.
Oh, yeah. Okay. Yeah, that's what I thought, but I wasn't sure.
And
Okay.
then this is how much I have to study. I got a whiteboard.
Yeah.
Awesome.
I have to pass this class.
Okay. So on the homework, did anyone do the homework then?
Yep.
I did.
Good for you. I don't think I've. Oh, I got to 13.
Oh,
Oh,
that's
that's good.
Oh, you're pretty much done.
Yeah, 2 left.
okay. Do you guys have a question on it, or should I just go?
I didn't have any.
Go.
Yeah, if you have
Oh.
a question, go for it.
Okay. So on number 3, it says, what was the shape of the distribution of sample means? And it was skewed right. But then on number 6, it's asking what was the shape of the distribution sample mean, and it's supposed to be normal, I believe. So how can I tell the difference? Like, because both of them, the explanation talk about it being right skewed.
Okay.
So in this class, in the reading, it says that anything above 30 or any sample size above 30 is considered a large sample.
Mm-hmm.
So when it's a large sample, it's safe to assume that the distribution will be approximately normal.
Normal. You're right.
So you look at the 30 hours.
100 students.
Yeah,
Okay.
the 100 students that were.
That was because
Oh.
that makes sense. Okay.
Yeah.
And then I was going to ask if the mean is always the same with the sample and the population. And you said you read that, Tori, somewhere?
Yeah, I wrote that down, so I'm assuming I read it.
Yeah.
Hopefully I'm not saying it wrong.
Yeah.
And
That's
for
what we've seen on all of
individual
them.
Okay.
Yeah, I didn't write it down specifically, I don't think, but wouldn't make sense.
Let me see where I found that in the reading, just so that you can be sure.
Okay.
So now I'm not seeing it.
You're talking about the mean? Let's see.
Yeah.
Is it under? What did you say? Sample mean will be approximately normal if the sample size is sufficiently large. Is that?
No, that's the distribution.
Oh, okay. But when
I'm trying to find where I got, because I wrote down somewhere that the mean is the same for like, I just have mean and then the symbol on the X bar of sample mean is the population mean. But I don't know.
I'll check notes too. Let's see.
Okay, here we go.
If we look at the question, though, there's
Okay.
really no way we could figure out another mean without
Yeah.
data.
That's cool. So it has to just be that.
It says, so mean and standard deviation of the distribution of sample means. The following facts are always true. They do not depend on the central limit theorem. They do not depend on the sample size. These facts hold for the sample mean, which is X bar, of any simple random sample of size n, so any size sample, drawn from a population with mean, and then it has the magna or whatever you called it.
the mu.
Mu, yeah, and standard deviation. I'm reading under section 4. So it says the mean of the sample mean is, and then it's got that that thing. So the mean is the same. Yeah.
Yeah, that's what I've got too. So.
And then it has the formula for standard deviation of the sample mean.
Okay.
Anyway, so yeah.
Okay, perfect. Thank you so much. And then, was that my only question? I think that was my question.
Okay.
Okay.
Do we want to attempt the quiz? Shall we?
Yeah, sure.
Okay.
Okay, so we're doing number 6, group meeting.
Yep.
I don't want to open up the wrong test. I kept that test.
Oh, yeah.
Whenever I opened it, I kept it
Oh,
open
yeah,
all
that's
week, and I
true.
just used another browser for the.
Oh, my gosh.
and I still didn't do well, but okay.
Okay, so 1 and 2 we can answer on our own. Okay. When using the when, okay, maybe when taking. Do you guys have that on yours? Does it
Yeah.
say when using the when? Okay. I'm
Yeah.
gonna start. When taking samples of n equals 5, what was the shape of the distribution of means histogram when the parent population is right skewed? So it'd be skewed right. That's just confusing because all the
Yeah.
wording is messed up.
Yeah.
But skewed right, right?
When using the when.
Yeah.
Yeah.
Okay. When taking samples of n equals 100, what was the shape of the distribution of means histogram when the parent population is right skewed?
That would be
So that's
normal.
normal. Yep.
When using the sampling distribution applet, when n equals 5, what was the shape of the distribution of means histogram when the parent population is normally distributed? Normal, right? Well,
Yeah, isn't that the thing we did yesterday? Well, not yesterday, but where we simulated like.
getting samples or whatever. Yeah, it was where I'm trying to find that website.
5 was still like a solid. It kept it normal, right?
Is that when we had to switch it to 10 to make it actually look?
Yeah.
Did we?
Uh-oh. Here you go.
Well, let's see. It says the parent population is normally distributed, so that would mean
Oh, then it'd be normal,
that it's
right?
normal, right?
Okay. Yeah. We're thinking too
Based
much
off
on
of
that
the
one.
5. Yep, I know.
Okay.
Okay, so then when taking samples, when n equals 100, what was the shape of the distribution of means histogram when the parent population is normally distributed? It'd be the same, normal, right?
I think it'd be. Isn't it true? Like whenever the parent population is normal, then the sample will be normal.
That's what I was thinking. Yeah.
There wasn't any example where it wasn't.
Oh gosh.
No.
Guys, I have to change a messy diaper.
Okay.
Okay, start. It's like,
Everywhere?
it's kind of bad. So I'll be like 2 minutes, 3 minutes maybe.
No worries.
You guys wait for me. Okay, I'll be back in just a second.
Yeah.
It's a blowout. Okay, so you're saying that when the parent population is normal, then it's usually normal.
Yeah, the population mean will always be normally distributed.
Always. So they're just trying to test us to see if we understand always.
I think so.
When would it?
Wait, that's weird.
What's weird?
Oh, I was just gonna look at number 3 again. Oh, okay. Yeah, so it's different. Never mind.
It's skewed right?
Oh, and in number 3, it's skewed right. I was just wondering if 3 was like the same scenario as 5, but it's different. So.
Because one's skewed and one's normal.
Yeah. Yep.
Okay.
So do you guys know if for our tests we can have like a note page or something? I thought I remember her saying something about it, but I didn't want to like mix it up with another class.
I think, didn't we get to have like one paper? Like
Yeah.
That's kind of what I thought. but I
Yeah.
couldn't remember if it was her or another teacher. And I think we have a test next week.
We do on lessons 1 through 7. Yeah. 1 through 7.
Do we have a final in this class? Do you guys know? I haven't looked.
Let's see. I don't think so. I think it's just Unit 4 exam.
Okay. So I love when it's not comprehensive. Oh,
Yeah.
Oh, me too. Yeah, that'll be good.
yeah, that'll be helpful.
There's a group project. What is that?
I think we have to do a group project too.
Sorry, that was like almost blowout status.
You're good.
No wonder she was fussy. Okay, and now she wants to nurse. Sorry, hold on just a second.
Being wrong.
Brittany's good at education. When you talk to your friends, yeah, I'm with these 3 crazy ladies. One's really old. One's.
No.
Yeah, we're lucky to have you.
Poor Britain got stuck with all the girls.
I know.
We're lucky.
We are. Okay, so sorry. I'm back.
Okay. When would the distribution means be normally distributed? Choose all correct responses. Data are drawn from a population that is normally distributed and the sample size is small. Data are drawn from a population that is normally distributed and the sample size is large. Data are drawn from a population that is right-skewed and the sample size is small. Data are drawn from a population that is right-skewed and the sample size is large.
So that would be like the first 2 and the last one, right? So not the third.
That's what I would guess.
Yeah.
Yeah, that's what I'm thinking.
Data drawn from the cell size is small. Okay, so why didn't you pick 3?
Because when it's right skewed but the sample size is small,
Right.
you can't assume that it'll be normally distributed, but when it's big,
You can.
then you can.
It would be right-skewed.
Okay,
Yeah.
so number 1 is normally distributed. That's why it doesn't matter if the sample size is small.
Yeah.
Okay. All right.
Okay.
Okay. Number 8.
I'll do it. Which of the following gives the best explanation of the central limit theorem? If the parent population from which the data are drawn is normally distributed, then the sample mean x will follow a normal distribution. Do you guys call that x, by the way?
I mean, it's X bar.
X bar, whatever.
Okay, that's x bar.
We-
Okay.
I don't care.
There's a bar over the top. Yeah.
Okay. For bell-shaped data, approximately 68% of the data will be within 1 standard deviation of the mean, about 95% of the data will be within 2 standard deviations of the mean, and approximately 99.7% of the data will be within 3 standard deviations of the mean. If the sample size is large, the sample mean x bar will be close to the population mean. If the sample size is large, the shape of the sampling distribution of the sample mean x bar will be approximately normal.
It's that last one, right? The
If it's
central
lower.
limit.
If it's
Sam.
if it's big, then it should be close. Then it should be normally distributed.
Either 1 or 4 could be right.
Well, I don't know if I think it would probably be more 4 because the CLT is focusing on it being a large sample.
Yeah, I agree with you.
Isn't that the rule of large numbers, though?
No, so the
Oh, go ahead.
okay, I was just gonna say that one means that the mean, if the sample is large, then the means will be close to each other, like the sample mean
It's
and the
standard.
population mean or whatever, and the standard deviation gets smaller.
Uh-huh.
That's the rule of large numbers, right?
Okay.
Yeah.
Jenny?
Yeah,
Or-
the large number-
Yeah, I'm looking at the definitions right now, and yeah, that differentiates them all.
Because the number 4 is it's not talking at all about the standard deviation. It's talking about
Yeah,
across the
it's true.
normal. So it's that
Yeah.
normal distribution we're looking for.
Yeah.
So it's the
Yeah,
first.
that makes sense.
Because the number 3 would be the rule for large numbers, but number 4 I think is for this.
Yeah.
Mm-hmm.
Yeah, it is.
So it's the last one?
Yeah, I think.
Yeah, I think we're right.
Okay.
Okay, so then next one. Let x be a random variable with population mean 10 and population standard deviation 6. Suppose a sample of size 36 is drawn from this population. What is the mean of the distribution of sample means? It's 10, right?
Yeah.
The same. And then for 10, what is the standard deviation of the distribution of sample means? So this is when we need to whip out our calculators.
And talk this through. How do you put it in?
So it's going to be the sample size, or wait, the standard deviation divided by the square root of 36, right?
So 6 divided by the square root
6.
of
Yeah,
30.
so it's going to be 1, right?
Yeah, that's what I got, but I feel like I need to do it again.
I know, but when they say round 3 decimal places and then you don't get a decimal,
It's scary.
yeah.
0, but
Oh,
that's
yeah.
why I'm like. But you're supposed to do the standard deviation.
Yeah.
I mean,
What's
6
wrong, honey?
divided by the square root of
n.
Yeah,
which is
6 divided by
36.
6.
That
So
is, I mean, I think we just have to do 1 decimal point 0, 0, 0, right?
Yeah. Are you
I
all
think so.
done?
You're doing point 1. What are you doing?
You just do 1, 0, 0, 0. I don't know.
1.000.
I'm sorry, what did you say?
Number 10, we have to do 3 decimal places, so it's 1.000.
Yeah. That's what I'm... Hey.
it's weird that it asks for the distribution of samples.
Regardless of the distribution of the population. Are we all on 11?
No, I'm on 10 still, just trying to.
Still working it out.
Because that, so standard deviation of sample means. Is that what we just found? Standard deviation of the distribution of sample means. Is there a difference between with that word
Yeah,
distribution?
I think there is, yeah.
Oh.
Because the distribution is like the graphic, isn't it?
Let me... Oh, of course, I just exit out of the...
Test?
No, the textbook. Yeah, no, that would not be smart of me. Okay.
Oh, the distribution of sample means that we're saying? So this says it's a distribution of all possible sample means for X bar for a particular sample size. It has a mean of and standard deviation of, yeah, formula.
So we're right? Or we use the right formula?
According to my notes, if you look in the textbook, if you go to the review section of the textbook,
Okay.
go to that and let's read it.
Uh-huh.
And that's where I wrote that down from. So go to the end of that text.
Yeah.
And it says the distribution
Of sample.
Do you see that? Remember, like that summary?
Yeah.
Yeah, and yeah, it's the same formula that we just used.
And that's talking about the distribution of sample means. So I think we did it right. It just looks weird.
Yeah.
I don't know.
So, are you putting the 1.00?
Yeah.
Okay, okay.
Did you guys do 1 and then .000?
Yeah.
Yeah, it came up in a window for me. Like I put 1 in, and then it came up a bubble window, and it said 1.000.
Really?
Huh.
Yeah,
Okay.
Well, guess we're good.
All right.
it's a sign. Okay.
Okay.
Okay, so 11, regardless of the distribution of the population, if the sample size is large, what would be the shape or distribution of the distribution? Wait. Oh, I just read it. Okay.
The
The
shape-
distribution of the sample
Normal.
mean. It would be normal,
Yes.
right?
Yeah.
What
And
theorem?
then, yeah, what theorem would justify your response? That would be central limit.
Yeah.
Okay, I'm submitting it.
Okay.
Let's see.
You guys are awesome.
Guys, why do we always like stress about silly problems when we have it right?
We work for our A's. We work for
Thank you.
Oh,
them.
good.
Awesome.
Wow. Okay.
All right, easy peasy.
Yep.
Lemon squeezy.
Quickest day ever, I think.
It
Yeah,
is.
that's a record for us, for
That is a
sure.
record for us.
Yeah.
Enjoy the devotional. Oh, and by the way, Natalie, where do you live?
I live in North Carolina.
Oh, I was way off. I was like, I think she was in
Okay, we
Texas
were way
or
off.
something.
Oh, I just moved from Texas. Like, I was in Texas about a year ago, so we've only been here for about a year.
Oh, okay. Maybe that's where I...
Oh,
What part of
okay.
Texas were you in?
Austin.
Okay, so my husband interviewed in Austin for medical school, but we haven't heard back yet. So
Good
we don't
luck.
know if we're accepted or rejected.
We loved it there. You'll love it.
Interesting.
Yeah.
Um,
Did you ever do Franklin's barbecue when you were there?
Yes.
Yeah, we
Are huge barbecue lovers and food
Yes.
lovers.
yes. We
Um,
went to San Antonio and to visit my sister-in-law, and we went to Austin just to go to Franklin's.
Awesome.
It's that good, huh?
Where are you guys from?
I'm in Mesa, Arizona.
Arizona. Britton's in Idaho right now. But Britton, where are you originally from?
I'm from Idaho. Just like
Okay.
an hour away in Pocatello. Hour and a half.
Okay. And what about you, Jenny?
I'm in Peoria, Arizona. So,
I used to live in Peoria.
are you serious?
Not just for like 3 months for an internship, but still.
Oh, sweet.
Yeah, we just lived like 5 minutes from the new temple, the Phoenix Temple.
That's so cool.
Yeah, where did you
Yeah,
live?
that's-
This was like 10 years ago. We lived, I don't know, in some apartment complex that was close to Honeywell for my husband to do an internship.
I know exactly
Okay.
that place. No, just kidding. That's awesome.
Okay, we're snowed in. My kids have had no school Thursday, Friday, Monday, Tuesday. Like, we've just been
Oh, you
snowed in.
Oh,
guys got
really?
hit with that crazy
Yeah,
storm.
we got hit with it. So. It's been fun, though. It's been really fun. Anyway, I know you guys have got to go. We'll chat later.
Yes.
Wow, fun. Stay warm.
Yes,
Thanks.
All right.
Yeah.
Take
Bye-bye.
care, everybody.